Hello there, this is Alana Tuckey, and I've received a request for help with 11.2, number 7. The T afterwards means this is going to be a technology problem, so we're going to use either the calculator or StatCrunch to find some of the critical components we'll need. All right, so we're going to start off with, let's click View an Example. It says the accompanying data represents the muzzle velocity in feet per second of rounds fired from a 155 millimeter gun. For each round, two measurements of the velocity were recorded using two different measuring devices with the accompanying data obtained. Okay, so let me see if I can set the stage here. So I'm going to copy this to the clipboard, and then I pasted it into my Word document, or you could paste it into Excel, or if you like, you could paste it into StatCrunch. You're going to need StatCrunch eventually, so right there will work as well. So you can see what's happening here is you're firing this 155 millimeter gun, and then you have measuring device A and measuring device B measuring the muzzle velocity, how fast the projectile is coming out of that muzzle. So this device A measures it at 794.9, this device B measures 794.5, and so on. Then you have another shot, and both devices measure it, and then you have a third shot, and both devices measure it. So this is rather obviously a dependent sample. Couldn't be much clearer because it's two measurements on the same group of things. So you have one group of gun firings, 12 group of gun firings, and you're measuring each one of those gun firings twice, once with device A and once with device B. Okay, so two measurements on the same group, that's dependent sample for sure. Now, part B is the long part. It says, is there a difference between device A and device B at alpha equals 0.01? Let me click this. So right there, is there a difference at alpha equals 0.01 level of significance? It's a very benign sounding question, but it's actually a huge hypothesis test. You're going to have to run this hypothesis test, as a matter of fact. This is the one from the inferential statistics info sheet that you get to use on your exams. So notice it says testing a hypothesis regarding the difference of two means. Well, that's what you're looking at. You're looking at the average muzzle velocity, and it's matched pairs, which is what you have in this data. You have pairs of data that are going one for each gunshot. And this is going to be a t-test on the calculator when we get there. So we have all this stuff. First thing you're going to have to do is all these different steps, and you're going to have to set up your hypotheses. When it says, is there a difference, question mark, it means you're going to have to conduct a hypothesis test. So you need all steps 1 through 6. So step 1, we needed hypotheses. Well, they're not talking about is device A lower than device B, or is device A greater than device B. They just say, is there a difference? So that's a classic equal, not equal. You just want to know if they're different from each other. So step 1, your hypothesis would be that the mean difference is 0. You assume there's no difference, that's the null. And the alternative to that is that there is a difference, which means that the mu d is not equal to 0. Somehow device A and device B are significantly different from each other. And the d, of course, stands for difference, for subtraction. Step 2 is everybody's favorite step. That's your alpha. And alpha is almost always given to in the problem. In this case, it's 0.01, so you're done with that. Step 3, you need your test statistic. Okay, well, you can get this a couple different ways. To do this, it's easiest to just run the test either with the calculator or with StatCrunch. So let's do that. So it's d bar over SD over the square root of n. Let me use the calculator first. So if I go to Stat and I go to Edit, you can see that I've already typed in measurement A and measurement B. So what I need is the differences, because I want to run a t-test, but a t-test is over a single column. And right now I have 2 columns. So I'm going to go up to the top of L3. I'm going to say second 1, which is L1, see it right there, minus second 2, L2. I'm going to press Enter. And it's going to calculate the differences for me. It's taking 794.9 minus 794.5, and there's the difference, 0.4. Then 794.2 minus 795.1, and there's the difference, and so on. All right, that is the column that I'm going to run the tests on, because I really want to run the test over the differences. So I'm going to go to Stat, I'm going to go to Tests, I'm going to pick number 2, t-test, because that's what the inferential statistics sheet tells me to do. Up at the top, it tells me I want to run a t-test. So that's what I'm going to do. So number 2, t-test. Now, you want data here because you actually have a column of data. You don't have just numbers given to you. So I'm going to select data. My null hypothesis is 0, so right there 0. My list is L3. That's where all my data is calculated because I really want to run it over the differences. I don't care what the actual numbers are. In this course, we always leave frequency as 1, so leave that alone. And this part is really important. You've got to select the correct alternative hypothesis. In this case, it's a not equal to test. So I want that one to be dark. So make sure that it's nice and dark. If it's not, if it's, here, let me show you. If this one's dark, see how that? Then you get your blinking cursor on the not equal and press enter. And then when you move off of it, it should be dark. And then you go down to calculate and press enter. And there you have it. This top line right here is the test statistic. Right there, actually the top line, tip-top line, is telling you what your alternative hypothesis is. You can double check that. You wanted a not equal to, so that's correct. There's your test statistic, 0.676. There's your p-value, which is 0.513. There's your d bar. Now the calculator thinks it's x bar, but we know better. We know this was a column of differences. So this is d bar is 0.1166, and s is about 0.598, and n was 12. So I can go into the formula and can say this is 0.598 over the square root of 12. That's about, let's see, 0.1166 over 0. What I had before, 173. And I can see that test statistic is 0.676. That's my T0 test statistic. Now in StatCrunch, let me run the same thing so you can see it. So StatCrunch, you don't have to find the column of differences, it'll find it for you. So StatCrunch is a little bit nicer like that. So we want to go to T-stats right here. You want to go to paired, click on that. We have column A. A is where sample 1 is, sample 2 is in B. I'm going to save the differences. I want to do a hypothesis test equal to 0, not equal to 0. And then I'm going to click compute. And there you can see, same test statistic, same p-value. It doesn't give you standard deviation, it gives you standard error. See that 0.173 right there? So if I go back to the problem, you can see it. That's where this denominator 0.173 came from. So 0.598 over the square root of 12. So if on an exam I give you this part over here and not the calculator, what I could ask you to do is say, hey, the standard error is 0.173, calculate the standard deviation. In which case you'd have to do this. Standard deviation over the square root of 12 is equal to 0.173, and you'd multiply both sides by the square root of 12, like this. Oops. Square root of 12 to both sides, in order to find what the standard deviation approximately was. It's about 0.599 if you do it that way. If you use the calculator gives it to you. Conversely, I could give you the calculator output and ask you for the standard error. So both of those are problems you should know how to do. All right, now aside from that, there's the hypothesis test results. You can see it's giving you the test statistic right there, 0.676, up at the top, 0.676. There's step 3, and also step 4, because it tells you the p-value is 0.513 right there, p-value is 0.5133 right there. So now for step 4, you have to draw a picture. Especially if you're doing this on an exam, you got to draw this whole picture with the normal curve. You've got to label each one of these pieces. So this is negative 0.676 on the left. It's positive 0.676 on the right. Okay, and then the p-value, you do a double-sided arrow and say those two areas together make 0.513. All right, then you have to make a decision. Is there a significant result or not? You say, no, I do not reject the null hypothesis, because you reject the null hypothesis when your p-value is low, less than alpha. But this p-value is far from but less than alpha. So 0.513 is greater than alpha, so you do not reject. Or you could say not less than alpha, or you could say greater than. Either way. That means there is not enough evidence to support the claim. When you do not reject, there is not enough evidence to support the claim. What claim? Well, if you look back in the problem, it says, is there a difference in the measurement of muzzle velocity? That's your claim. Right? You're claiming there's a difference, that the mu d is not equal to 0. You couldn't get enough evidence to prove that. Doesn't mean it's not true. It just means we didn't have enough evidence to prove it. It's possible these two devices are different from each other, but we don't have it to prove it with our p-value being that large. All right, so we have done all of step or excuse me, part B, the hypothesis test. We did a little bit more than MyMathLab was strictly asking for, but all this stuff in here is what you'd have to do if you have to do it by hand, so it doesn't hurt to see it. All right, part C wants to know, I'll flip through all this. See, construct a 99% confidence interval. Well, that's not too bad. I'll do it with the calculator first. So you go to Stat, go to Tests, and you want a t-interval. Just like you wanted a t-test, you want a t-interval. And you can also learn that from the inferential statistics info sheet. Up at the very top, the first page right here, when you're looking for dependent samples, see right there? So you're doing a two-sample mean with dependent samples, i.e. a paired sample. That's a t-interval. Okay, so I'm going to grab t-interval number 8. Again, I have data, so I'm going to leave that data. Again, it's L3. Frequency always leave as 1 for our course. I'm going to set this to 0.99, which it already was in this problem, and go down to calculate and press enter. And there's the interval right there. And then look again, there's D bar again, there's SD again. On StatCrunch, let me do it again. You go to edit, or here, you don't even have to do that. Stat, T-stats, paired, A, B. I don't really want to save the differences this time because it's the same differences I already found. So I'm going to click confidence interval. I'm going to put 0.99 and click compute. And they're the same numbers that the calculator comes up with. So either one is fine. And again, you should be able to read this output for the sake of an exam. Okay, so let me put that in there. Oops, it already is. So there's my confidence interval right there. Now it asks us to interpret this, so let's think about that for a second. If you have 0 in the interval, see how 0 is in this interval? That means that there's not a significant difference. A significant difference to you is the alternative hypothesis, that mu d is not equal to 0, that alternative right there. If you have 0 in your interval, then you're sticking with this null hypothesis right here. Because 0 is in the interval, you assume that that null hypothesis is holding true, because you can't prove it otherwise. What would matter to you is if the confidence interval didn't have 0 in it. If it did not have 0 in it, that would imply there's a significant difference. So just a little hint there. Since 0 is in that interval from negative 0.4 to positive 0.6, that means that it implies that there is not a significant difference between device A and device B. All right, next it wants us to do a box plot of the differences. So let me do that real quick. If I go to, let's see, stat plot, so second y equals, I'm going to pick number 1. I want it on, so press enter to make it on. And then you want a box plot. You want this one with the little dots after it, so press enter. And you go down here, and my X list is in L3, so second, 3, enter. And then all that said is we always want frequency 1. I want the little boxes. I'm going to hit zoom, number 9. See 9 down there? 9. And there we have a box plot. Okay, and then I can do it again with StatCrunch. StatCrunch is actually probably going to be a little bit better. Here, let me delete all this. Okay, so I go to StatCrunch. I'm going to hit graph. I want a box plot right here. I want it of the differences. I'm going to use fences to draw or to identify outliers. I'm going to draw the box horizontally. That's all good. So let me click compute. And there it is. So I'm going to copy, right click, copy image. Let me see if I can paste this in here. There, I had to paste special, but there it is. All right, so we have a box plot. Lovely. All right, let's see what they want from this. So construct a box plot, we did that. And then we did that. It matches basically what we already thought, which is notice in the box plot how 0 is right in the middle of things, right? 0 is this line right here. 0 is this line right here. Since 0 is part of this box plot, that implies there's not a significant difference. Let me type that up. There we go. Since 0 is contained within the box plot of the differences, that implies that there's not a significant difference here. Again, significant difference would be that they're not equal to each other. 0 is not in there. Since 0 is in there, that's not a big deal. All right, I hope that helps. I'll see you back here for more tutorials.